Good evening, Cougars. Or should I say good morning, since you're probably watching this at 4 a.m. off of 5 energy drinks. Today's topic is a very special one to me, and that is the mixture problems. It's probably one of the most fun ones to do in all of linear algebra. So you know the drill, you don't gotta study, cause you got me. So, let's get right into it, shall we? Fun.
So here we have the basic setup for pretty much every mixture problem you're ever going to see. We got the volume at time 0, the initial concentration of salt, the inflow rate, and the outflow rate. First thing we're going to do is we're going to set up an equation that derives volume with respect to time. All this equation tells us is that there is a net gain of 2 liters of water per minute. Now from that 2 liters per minute, we're going to combine it with the initial 500 liters of water that are already in there, and we're going to add 2T. So that means that the amount of water changes based on the amount of time that has passed. Really, really simple stuff. Now, one thing you guys have to know about these problems is that it pretty much always comes down to this same format. It's pretty much just going to be inflow times concentration minus outflow times concentration. Really, really simple to understand. Really not that hard. You gotta be a certified Mega Knight player if you don't understand this. Now, here comes the time that you guys have all been waiting for. We're about to Clash Royaleify this equation. Now, instead of water coming into a tank and measuring salinity and all that bullshit, I'm gonna propose a little make-believe scenario for you guys. Now let's say a greedy goblin of
Unknown employment history
has decided to pump Superfent, which we'll denote as this dark elixir icon, into the elixir pump tank, which we're going to call elixir. Now, why did the goblin pump Superfent into the tank? I don't know. That probably has something to do with Israel. Now, to figure out the concentration of the Superfent, we're going to have to divide that by the total amount of elixir that's in the tank. And that is going to look like this. It's going to be Superfent times T with the previously calculated equation that we just got. Now, if you guys remember this -3, that is the outflow concentration. Now, there is no inflow concentration, which means that we're just going to leave that part alone, and thus, this is going to have to be negative since we're subtracting it. Now, bringing this down here, all we did is rearrange it so that the Superfent is now on one side. So that means we can very easily take an integral, everybody's favorite. So, that integral is now going to look like, boom, where since the Superfent was in the denominator, it's going to be in a log natural. And for the other side, we're just going to take the -3 minus the log natural of the bottom function. So that just turns into log natural of 500 plus t. And since chain rule is still a factor, this 2t is going to turn into 1/2. And then, of course, our integrating constant, which is plus c. Now we simplify into -3/2 ln 500 plus 2t plus c. And ultimately that is going to turn into ln times absolute value of 500 plus t to the power of -3/2, because of course if you have an outside number being multiplied by the log, it can go into the exponent, and then finally plus c. And here's where we get to start doing tricks, guys. Alright, just like that goblin, we're going to pull some nasty tricks of our own. So, this plus c right here is technically equal to ln of e to the c, which is just going to be c. But if we make c equals ln of k, where k is literally just e to the c, we can turn this equation into ln of Superfent times ln of 500 plus t in absolute value form to the power of -3/2 plus ln of k. Now, remember guys, that an ln of a plus an ln of b is just going to equal ln of a times b. And so with that beautiful mathematical trip, we're just going to get k times 500 plus 2t over -3/2. Now we got rid of the absolute value because if you think about it for 2 seconds and you're not a complete moron, time can't be negative. So we're just going to assume everything here is positive. Therefore, we can bust away with those dumbass bracket bars that make everything a little more complicated to look at. Now, if we remember the initial condition that Superfent at time 0 has to be 10, we're going to plug in 0 for t. And if you rearrange it, k equals 500 to the 3/2 times 10. Now, we've officially defined our k constant, so we don't have any more undefined variables to worry about other than t. And now, finally, guys, we have officially integrated our entire Superfent equation. That is just going to be 10 times 500 3/2 times 500 plus 2t to the -3/2. That all looks very complicated, and in all honesty, it was kind of a chore to write out. But this is going to allow us to measure how much Superfent is left in the elixir collector. Now, if we rearrange the formula slightly by sending this 500 plus 2t to the denominator because it has a negative exponent, we are going to be able to take 10 times 500 over 500 plus 2t, all to the power of 3 over 2. That is a lot simpler and a lot more easy to calculate. But something crucial you guys have to know here, guys, is that since t would have to be negative 250 to break the equation, and t can't be negative, this means that superfent will approach 0 as t approaches infinity, but it never will actually disappear. Huh, that kind of sounds like something the CIA would do.
FBI, open up!
And that was the mixture problem, ladies and gentlemen. As always, thank you guys so much for watching, and if you guys want me to cover something in the future, please leave it in the comments below. I read every single one of them, and as always, you guys are the best, and thank you. So, please like the video and subscribe if you enjoyed it. Please share it with your friends if it helps them out too. That makes me even happier. And without further ado, peace.